All right, now let's look at another special case, the general trigonometric rule. So let's read through it. Let u be any differentiable function, then the derivative of sine of u of x. Now here again we have a composition. Sine is the outer function, u of x is the inner function. How do we differentiate this composition? Well, we differentiate the outer function, so derivative of sine is cosine. We keep our inner function plugged in, so it'll be cosine of u of x. And then we multiply by the derivative of the inner function. So this is chain rule, but it shows up enough where you just want to get into the habit of recognizing these types of compositions. And this is one where we have the trig. We have a trig function as our outer function. And our inner function here is u of x. And, you know, the formula here is written for sine, but this same process works for all of our other trig functions as well. So cosine, tan, cosecant, secant, cotangent. This formula works for those as well. All right, so what we're doing here is this portion right here is taking the place of this is the derivative of our outer function. So the derivative of our outer trig function. And then we also keep our inner function the same. We keep what was inside the parentheses exactly the same. That doesn't change. So we just keep that the same. And so this is the derivative of our outer function with our inner function plugged in. And then we multiply by the derivative of our inner function. All right, so we have the derivative of our outer trig function times the derivative of our inner function, whatever that is. And again, this is a similar setup for what we saw with the general power rule. Derivative of our outer power function times the derivative of the inner function. And again, the same setup for just the chain rule. So derivative of the outer function times derivative of the inner function. So again, the key concept here is what is your outer function? What is your inner function? All right, so let's do a little example. We have this function. We've seen it before. We saw how to break this function down into its pieces. So we have an outer trig function, sine, and then we have a function, an inner function, this polynomial x to the fourth plus 9x plus 3. How are we going to differentiate this? So let's see this in action. We're going to calculate h prime, the derivative. So we start by differentiating sine. So derivative of sine, if we don't remember, is cosine. We keep everything inside the parentheses there exactly the same. So that's our inner function plugged in again, unchanged. And then we take that result and we multiply by the derivative of the inner function. So we multiply by the x to the fourth plus 9x plus 3, and we multiply by its derivative. So what we have here, h prime of x is cosine, derivative of sine, our inner function plugged in, unchanged, that stays the same, and then we multiply by the derivative of the inner function. And so then if we keep differentiating, we get 4x cubed plus 9. That's the derivative of our inner function. And probably a better idea to put this in front, just so we don't get these terms all mixed up. So this polynomial is inside the cosine, and to keep this distinct, let's move this 4x cubed. We'll put it in front of the cosine there. So that just helps us remember how we're multiplying things. So there we go. We have our derivative. So again, this is a composite function, and we differentiate the outer function first. So derivative of sine is cosine. We keep the inner function part the same, and then we multiply by the derivative of the inner function. All right. In the next video, we're just going to see another special case of chain rule. So we'll see you there.